So thank you everybody for joining to this presentation. Welcome to our talk about how attackers may gain root access in your enterprise software service. But first of all, I would really like to introduce ourselves. My name is Pablo Artuso, I'm from Argentina. I'm today with my teammate Ivan Genoir, who is from France, and we both work as security researchers at the Unauthenticated Security Research Labs. We have been, for those who are not aware about Unauthenticated, Unauthenticated is a company which is focused on providing security for mission-critical applications. We have been in this field for the last 10 years, raising awareness, doing research, particularly for SAP and Oracle products. This is our agenda for today. First of all, we're going to start with a brief introduction. Then afterwards, we will have some few words about the main component of analysis of today, which is the solution manager. Then we have 3 different chapters talking about our research and the vulnerabilities that we found, and finally some conclusions and some recommendations. So let's begin with our introduction. What's SAP? So for sure, if you have ever discussed or talked about enterprise software, you already mentioned SAP once in your life. The reason to believe this is because SAP is one of the largest vendors, if not the largest one, in the world of enterprise software. On the left side of the slide, you can see some of the products of SAP, and you may recognize some of them. On the right side of the slide, there are some numbers about this company that I want you to know. For example, 77% of the whole transaction revenue of the world go through an SAP system. Other number, all Fortune 500 oil and gas companies are using SAP for the daily business. So I hope these numbers may help you to measure how critical and how widely SAP is being used. In this slide, we have an example of a setup that we are going to use all along the talk. We can better explain what we are discussing in different topics. So it's really important you understand how is it built, this setup. First of all, we're going to have 3 different servers. Each of these servers is running a SAP application. As almost every application, SAP application, they are running on top of a layer that is called SAP NetWeaver. And we have 2 different flavors of NetWeaver, Java or ABAP. As you can see in the screen, some of them are running Java, some of them are running ABAP. Just for your information, S4HANA is SAP NetWeaver ABAP. And also, as you can see, there are some of them running Linux and some of them are running Windows. Why do we have such a diverse setup? Because basically we want to show you that the attack that I want to present today, it will work no matter operating system, no matter NetWeaver flavor. Also, in our custom setup, as any other setup, it will have the solution manager. And now I will hand out the presentation to Ivan, who will explain a little more about this component.
Thank you, Partou. Hello, everyone. My name is Ivan Genoir, and I will continue to introduce our target for this talk, the SAP Solution Manager. The SAP Solution Manager is what we call a technical SAP system because there are no business data into it, and this is kind of system used only by SAP administrator to perform administration tasks on whole other SAP system. So this is a highly connected system on the landscape, and the big advantage of the SAP Solution Manager is that you can only use one system, this one, to manage all of them, and it's independent of the SAP version, OS type, etc., etc. So we can represent it like that in this picture. And to fully understand the SAP Solution Manager, you can compare it to a domain controller in Microsoft Word. This is basically the same things. Why we took a look on it? It's a bit obvious we took a look on it because we think this is the technical heart of the SAP landscape. If we compromise the SAP Solution Manager, you can jump on every other SAP system very, very easily. To continue to introduce the SAP Solution Manager, we need to speak about one of these agents. It's called SMD agent for SAP Solution Manager Diagnostic Agent. This agent, it's a little component. It's installed on every single SAP host, and the purpose of this agent is to manage the communication between the SAP system manager and the SAP Solution Manager. So you can represent it like that in the picture, and it's very important for this talk because we will talk about this in the future. The last thing, because the SAP Resource Manager it's a SAP NetWeaver, you can use the SAP GUI, the normal SAP client to connect into it. But also you can access directly using HTTP requests, because they are basically a web server hosted in the SAP Resource Manager. And this is where we start. So the next part, it's when we start looking on this kind of product, this is a huge product with a lot of entry points. The first question is where to start. In this case, we were interested about how the SAP Resource Manager handled the communication with this agent, how this communication work, and how the SAP Resource Manager manage it, basically. What we did is to search on the whole application provided by the SAP Resource Manager for a pattern like SMD agent, something like that. We highlight around 60 applications, and in this 60 application, we found around a bit more than 20. It's reachable directly using HTTP request. So it could be SOAP, POST, GET, etc. And this is a sample of what we found as web services accessible remotely. So we test all of them. Basically, all of them are authenticated, and some of them is not very interesting, some yes, etc. Eventually, we found this one, EEM service admin. And the true story was something like that. I provide the URL to Patu and say, hey, look what I found. It's look very, very powerful web services, but unfortunately, this is authenticated. And Patu sent me quickly back something like, no, it's not. And so we'll double check, and yes, it's not authenticated. There are no authentication need for access to this web services. So this is how entry point in this talk. So I'll let Patu explain what we found exactly here.
So yes, basically the application that I was talking about is called EEM, which stands for End User Enterprise Monitoring. Sorry, End User Experience Monitoring. And what is this EEM about? Basically, it allows the SAP administrators to create scripts that will mimic user actions. So once the script is created, you can upload it to this so-called application EEM, and then this this script will get deployed to a different component, which is called EEM robots, that can be running in different servers, and there are the ones that are going to finally execute those scripts. Turns out that SMD agents are, by default, could act as EEM robots. So if you connect to the solution manager, you upload a script, then afterwards you can deploy to one of your SMD agents. But what is the final objective of this application? Basically, it allows SAP administrators to ensure that everything is working and avoid final users to experience some kind of error. So let's explain it with the following example. Let's suppose that at your company, users are really used to query some particular table of the database. So what an SAP administrator could do is develop a script that will basically query that table and deploy to an SMD agent. Once it's deployed, the SMD agent will start executing that script in a cron fashion, and in case it gets an error, it will be immediately notificate the SAP administrator. So doing this action, users will not, or potentially will not receive that error, because the administrator will get noticed before happening. But if you think for a little, Ivan told you that this application wasn't requiring for authentication. So this means that basically an attacker could perform the same, could create a script, upload it, and then get deployed. So that was our first question. And in order to answer it, and in order to have a POC of something that is actually working, we needed to be involved more in the application and how the application works. So that's the topic about our next chapter, which is basically a more in-depth and technical analysis of the application. First of all, in order to analyze it, we start with pointing to the endpoint. It was a SOAP endpoint. So as you can see on the left, we have all the methods that were available to be executed. One of them was called run script. So what we decided is, okay, let's go for this one because it has a good name. Good run script will ask for two different parameters. First of all, the host of the SMD agent or the agent or the EM robot where you want to run the script, and also the script name. When we first ran this test, we received an error that was not very happy because it said basically the EM was disabled. So we started looking how we can circumvent this issue. All along the different methods, we found one that was called getAllAgentInfo. That was really helpful because it was a getter function. This means that usually they don't ask for parameters and they provide really good information. And this case was not the exception. Once we get the answer of getAllAgentInfo, we saw that there was one particular property that was called EEM-enable and was set to false. So we start thinking maybe we can modify this and put it to true, and maybe that works. I don't know, it's just an idea. So we tried again looking for the different methods, and we found one that was called setAgeLetProperties. We went through that one and we tried to use it. Parameters were really easy to use because they were asking just the key and the value, so enable and true. And once we execute that, we went back and tried to execute again the getAllAgentInfo. And this time the property that was EEM-enable was set to true. And also we retest the run script, the first step we made, and the error was totally different. And right now made much more sense. The error was basically saying, hey, this name that you provide, I don't find it. It's not a valid script. Which makes sense because we were using some random script. Some random name for the script. And at this point we realized that, okay, we know how to run scripts now. The point is that we should try to upload our custom script. So how do we do that? We start going again through the methods and we found one that was called uploadResource. So uploadResource again asks for two parameters, the SMD host again, and also the content of the script. So this means basically that we have to upload what we wanted to be executed. The content was B64 encoded, that was not an issue, so we just encoded some random string, and the error was really, really interesting. It was basically an error, a really common error from XML parsers. So at this point we realized that maybe we are dealing with an XML protocol script. So we tried to encode the V64 of just the XML prolog, and the answer was really good also. That was basically that the XML parser was expecting for more information, but it found the end of the file. So at this point we realized that we were with some protocol, some scripting protocol that was totally related with XML. We started looking for more information about the context of the application in the web, and we found in the web that there was one particular example provided by ACP to perform an HTTP script. So we grabbed that script, we tried to modify it, and based on the errors that we were receiving from executing the uploadResource method, we were finally able to craft a particular script that was able to give us a server-side request forgery. So at this point we realized, okay, we have a nice POC for demonstrating that the unauthenticated attacker could perform some bad things. But if you think for a while, having an SSRF in an application that allows you to perform HTTP scripts is not something really, it's the nature of the application to do that. So we wanted to go beyond that and to try to find if there was a remote code execution over there. So it was a good time from our point of view to shift from black box testing to white box, try to analyze the log, try to analyze more files about the application. In these files of the application, we found the grammar of the scripting language, and this was really a game changer because we could understand more or less how was the scripting language composed. Each message, it was a message type-based scripting language, and each message had a different type. There are 4 different types that can be used, and one of those was command. So with that name, of course, we go through there and we try to analyze why was a command there? Why do you can have a type which is called command? So we start trying to understand which are the available commands for this scripting language, and we found that there were at least 6 or 7. At this point, we asked for ourselves, why do we have commands? Why this feature we have commands? And if you think it totally makes sense, and the reason behind that is because you can execute a request to some place, and you want afterwards to store maybe the answer in some place, for example, persistently in a file. So in that case, you could use a command like write to file. We start analyzing each of these commands in order to understand if we can abuse one of them, in order to understand if we can abuse one of them. And we finally got one that was vulnerable to a remote code execution. This command was allowing you to evaluate any JavaScript code that you want. We believe that something like what is shown in the script, in the slide, is happening beyond the application. There is a really common mistake from Java application importing a script engine from JavaScript and then passing all the string, let's say, that we want to evaluate that is basically a JavaScript code. With that vulnerability, this means that any person who is able to perform or to write their own custom script will basically be able to abuse this command and execute a remote code execution. The sanitization of the script string that was finally into the script engine of JavaScript was not there. I mean, there was not any kind of sanitization. So as a summary, this means that any person who is able to write scripts is able to perform remote code execution. But let's split this in two parts. Every person who is able to perform scripts, as we told you, this application is unauthenticated, so it means any person. And on the right side, which means that you can execute remote code execution in the SMD agents, which are the final executor of the scripts. This application is running as DAADM, which is the user for the SMD agents. So as a summary, basically this means that any unauthenticated user will be able to perform a remote code execution with the privileges of the DAADM. So here we have quickly the 4 steps that the attacker may perform in order to achieve this attack. First of all, you will gather all the information from the SMD agents, executing get all agent info. Then afterwards, he will choose the target and will modify the EEM enable property from false to true, basically turning off the EEM feature. Then afterwards, this attacker could upload a script which has a remote code execution embedded into it. And finally, the SMD agent will execute that code that was provided by the attacker. Here we have a quick demo of the attacker. On the right screen, you can see the screen of the attacker, basically that is executing an exploit that was built by Hiran. And you can see he's pointing at the solution manager, and you can see there, just right now, that there are some agents over there. There are 4 different agents. So if you recall our setup that we use as an example in the whole presentation, we have 4 different systems because we are trying to put the same thing as you can, so you can understand here. We are dealing with the same setup. On the left side, you will see how the different shells are starting to popping up. Basically, the attacker here is getting DAADM shells from each of the SMD agents which are connected to the solution manager. And even in the last one, as you can see, it's a Windows machine. So no matter if it's running Linux, Windows, the attacker is able to get a reverse shell from all the SMD agents that are connected to the sub-solution manager. So just as a summary, right now, the attacker is able to compromise all SMD agents connected to the solution manager, just having network access to the solution manager. There is no need for authentication, there is no need for authorization. This is just the step 1 of our whole attack. I will let Ivan to continue with the second phase.
Okay, so to understand the next step, how we would them all, we need to introduce a new agent again. The call of this agent is sub-host agent. So again, this is a kind of component installed on every single SAP host, and it's OS independent and database independent. The purpose of this agent this time is to provide some lifecycle tasks to administrators. So like monitoring, start instances, prepare for SAP upgrade or kernel upgrade, something like that. So this is a very powerful agent. Why we took a look on it? Basically, for three reasons. The first one is there are a couple of services of this agent run as root privilege, with root privilege. So of course, this is always a good, interesting thing to take a look on this kind of services. The second one, you can access to the services remotely using the port 1128. Okay, and the last one, the most important one, it's we find how the ADM user is listed somewhere in the configuration file of the SAP-host agent. So these three things convince us that we need to go deeper on it. So the next step is to try to understand how we can communicate with the SAP-host agent using how access the ADM user access. Okay, normally, locally, administrator can use the binary SAP-host control to call the function of the SMD agents. When we speak about function provided by the SAP-host agent, we speak about all this function. There are a lot of function, a lot of administration function. So. Next step is to we focus on the configuration file where we find the ADM user for sure. We find a couple of very interesting parameters. The first one is this one, this service admin user. Looking on the documentation, we understand that this is a list of users who are able to communicate with the SAP-host agent. So we are very happy because the ADM are in the value of this parameter. But unfortunately, after a few tests, we understand that even if we are logged as the ADM user locally on the system, we need to provide again the password when we call the SAP-host control. So we are a bit disappointed because in our case, because we use the SAP Resource Manager to execute the ADM OS command, we haven't the password, of course. So we can't communicate directly like that. Okay, the next parameter interesting in the configuration file, it's this one, the service port type. The documentation says this is a list of web services exposed by the host agent. So we take a look on the binary, and yes, there are a lot of web services available. And we look on the port 1128. So the 1128 it's an HTTP port where we can find a lot of all the web services provided by the SAP-host agent. And you can call the SAP-host agent function directly using this web services. And of course, everything is authenticated. One day, we decide to sniff the local network interfaces during our test. So we perform some tests we use in the SAP-host control binary, and we understand that behind all the process, it's only a lot of HTTP requests on localhost on the port 1128. So we get all the content of the web services, the SOAP request, etc., like that. The second thing we find during this operation, we find this very curious credential. The username, the pattern between brackets, it's always the same, but the password, the list of the number, change at every single request. And we are very interested about that because we don't know where this password come from and etc. So what we did, we decided to analyze the SAP-host agent kernel, and we start with as an entry point, we start with the username, the hard-coded username. And very quickly we understand that there are a feature named a trusted internet connection. So what we understand about this feature? For whole user list in the service user admin, for example, the ADM, they can call for a logon file, request a logon file to the SAP-host agent. The SAP-host agent send back the path, a local path to a file, for example, logon42. Then the ADM reads the content of this file, and the content of this file is the password, the temporary password you can use to perform one request. So it's meanwhile, this is very simple like that. One request on localhost, retrieve the path, get the content, and the content is the temporary password you can use. So it's mean what? It's mean at this time, we never provide the DADM password. So now, if we take back the global picture from the SMD agent as DADM user, you can call all the function provided by the subhost agent. And remember, when we speak about whole function, we speak about whole this function. So the next step was to find out how it's possible to execute root command directly using one of these functions. And we found a way using, for example, this function, execute operation. This function tried to execute subhost exec binary, but the path could be tricked by attacker. So attacker can execute command as root, what they want as root, as we're using this function. Another example is this function, execute install procedure. It tried to execute several commands as root, and the last command it tried to execute the subpath binary. But again, the path to the subpath could be tricked by an attacker, so you can execute what you want again. Another one is this one. This one is a little bit more tricky because it tried to mount a file system as root, but we found a way to trick the path to the file system, and we can provide a malicious file system with only one reverse shell into it and get a root reverse shell at the end. You get the point. We find several ways several vulnerability on the subhost agent to execute arbitrary OS command as root for Unix and Linux or system for Windows. So let me show you. This is basically the same demonstrations as previously. So we provide the subsolution manager hostname, the port, and it lists all the SAP host connected to the subsolution manager. And this time, instead of only get the reverse shell from a DADM user, we try to exploit the vulnerability of the subhost agent to directly get a root shell. And this is what appears on the left. The first pop-up, it's a root shell of the first system. The second pop-up, it's a root shell again on the second system. The third one is a root shell on the subsolution manager itself, because subsolution manager have SMD agent and a subhost agent. And the last one, it's the same from a Windows system. So as you can see, this is a very quick attack and very reliable because we use we use the same vulnerability. The only thing changed, the payload changed, but the vulnerability is the same. And now I'll let Patu explain how you can protect about it.
So we have invested some time talking about the vulnerabilities and basically our research. Let's invest some time also in recommendations. So we are going to divide this part in two. First, we are going to talk about prevention, and then we are going to go for detection. So starting for prevention. For the EM application, there is some really step that you can do, which is really manually. You just go to the solution manager, to the configuration of your application, and you are able to add authentication to this application. Of course, this is not the full patch. This is just a half patch. If you have, if you are able to, and you should do it, you should go for the full patch that was released by SAP on March. For the host agent attack, it's almost the same. We don't have, unluckily, kind of safe of half patch. We just have to go and install both patches that were released. And once you install, you will see that the DADM user is no longer available to execute host control functions. These previous recommendations were about application layer, right? But if we go to the network layer, there are still things that we can do. For example, one of the best things we can do is to try to avoid everyone to access the solution manager and just let your SAP administrators to go through a network and only access the solution manager. Filtering this will guarantee you two things. First of all, you will be reducing the attack surface, which is really important. And second of all, you will be able to be protected against future vulnerabilities that will remain also in the solution manager, as only the SAP administrators will have access. And remember, the solution manager is the heart of the SAP implementation. So therefore, keeping us updated as possible and as secure as possible is really a mandatory thing to perform. On this slide, you have some versions, the safe versions of the affected components by the vulnerability that we present today. So what you should do with this slide is grab these versions, go to your company's SAP systems and compare it. If you are under these versions, you are vulnerable. If you are at least in these versions, you are secure to the vulnerabilities that we discussed today. And why I'm telling you at least in these versions? Because the vulnerabilities that we present today were not the only outcomes from the research that we performed. We have reported several vulnerabilities during this year, and we have here a complete list or a semi-complete list of all the vulnerabilities that were affecting to the solution manager that we reported. So you should also go through this list and try to install those patches. In terms of detection, what we can do? Well, for the EM application, there is an easy way to go and turn on a log from the web, from the solution manager, that will allow you to log all the actions that this vulnerable application is doing. So afterwards, you can go to that log, you can monitor it, you can read it, and you can try to understand if something happened or something is happening right now. For the host agent, we have almost the same thing. Unlikely, it's a little more difficult to turn it on, but anyways, there is a guide of SAP telling you step by step how to configure it, so finally it's really easy. And after configuring, you will have two different logs that they are gonna have a lot of information, very verbose. It will be different, a little bit difficult to parse it, but at least you will have a source of information where you can get the actions that are happening on this host agent. And right now, I will hand out again the presentation to Ivan so he can close our presentation.
Okay, as a conclusion, we'd like to share three things. The first thing, we would like to summarize the attack. So remotely, an attacker can access to the subsolution manager, but this is just a little restricted access. But using this access without authentication, using this access, you can execute command as the ARDM on every single host on the SAP landscape. And with this connection as the ARDM, they can exploit some vulnerability on the SAP host control to execute root command or system command at the end. So, okay, this is very dangerous threat. And the second thing we like to share is about post-exploitation. This is a classical slide we provide about post-exploitation on SAP system because it covers the three big parts: espionage, fraud, and sabotage. We would like also to show you directly what is possible to do. So this demonstration starts at the end of the previous one. So now an attacker has full access of the system. He can retrieve information of the SAP system, and he can try to log with a malicious user. For example, Professor Moriarty in this case. It's not work, but because he has full access, he can download the script, execute a script, and what the script do is to create the user on the database, to create the SAP user directly. And of course, this new user is equivalent of administrator user. Now it can do a lot of things. For example, display the HR data of everyone in the company. So like, bank account, salary, etc., etc. So this is all about we call espionage. About fraud, what is possible to do very quickly is to, for example, change an IBAN of a company. So the attacker select the target company, for example, Dupont, a very well-known French company, and there are an IBAN registered in the system. And again, you can execute a script to change this IBAN very quickly, and now the IBAN is changed to the attacker one. It means what? It means the next time a money transfer is done to this company, the money go on the wrong side. So this is all about fraud. The last, it's sabotage, and of course, because attacker have full access to the system, it can stop the SAP system, delete file, delete backup, delete everything. So this is everything about post-exploitation, why it's very dangerous. So the last thing we'd like to share, the most important thing, it's the SAP Solution Manager is a great product and a powerful product, but it's very, very, very important to secure it. So take the SAP Solution Manager in your SAP security process, etc., etc. There are no business data into it, but the power of the SAP Solution Manager could be very dangerous. So secure it, patch it, do everything you want. You can. So also we put all the references of the patch related to all vulnerability we find. Also, thanks for everyone involved in this talk to perform this talk, and that's all for now. And we wait for your question. Thank you.
So thank you everybody for joining to this presentation. I hope you enjoyed all our research. We have been reading only the questions that you have asked. We have only two. So I will answer quickly the first from Sophia, that she asked if we're gonna have if they wanna have the slides available. Yes, the answer is yes. We don't know when, maybe late today or during this week, but we are not very sure about that. And the other questions, I will leave it to Agon.
Yeah, there were a question about the since the vulnerability are within the agent, does this issue impact all SAP system, not just the Solman? Not sure why we are calling this Solman specific vulnerability. So this is a question. Yes, it impacts whole SAP system with the SAD agent installed into it, and we call it Solman vulnerability because the SMD agent come with the sub-solution manager solution. So if you have a sub-solution manager, you have SMD agent, but if you haven't sub-solution manager, it's very unlikely. You haven't SMD agent. So the answer is yes. Whole SAP system with the SMD agent is impacted by this vulnerability. I hope it answers the question.
Yes, and sorry, but we have one question more from Patrick, who asked, will you share your scripts too? Unfortunately, we are not going to share the scripts. We don't share any kind of exploitation scripts. So no, the answer for that question will be no. Sorry.
We get also a question about how long did this process take? We start looking on sub-solution manager in last December, if I remember. We work on December, January, and February on it. And so for, yeah, this is like two or 3 months, two researchers doing 2 months, maybe 3 months. But we also find not only this vulnerability, we also find I stopped counting, but we find like 15 vulnerability or something like that on sub-solution manager and the sub-host control as well.
Yeah, and we have one more question from Pedro asking if are they similar vulnerabilities with Oracle? Well, I'm particularly myself, I'm not really into Oracle Word, but there are some critical vulnerabilities that the Onapsis team has reported. So the only thing that I can tell you is maybe you can find those vulnerabilities and I don't know, and try to read from them. But it's really difficult to tell if there is some similar vulnerability like this in Oracle. So yeah, maybe you can go of the resources of Onapsis and see one vulnerability that is called Big Debit. Maybe that will help you. And I think that's all.
So we have a last question. Maybe, I don't know if we have the time. So what was your experiences with the way a SAP responds to your disclosure? I don't think I get the question about disclosure. Basically, we share our works with SAP response team, and so we never disclose POC or full exploit, and that's it. I don't know if you, Pato, you have something to add to this question, but.
No, I think it's okay. The answer, what I would add is like whenever we disclose or whenever we report one vulnerability to SAP, they were really quick in patching these vulnerabilities. So yeah, so kudos to them that they really do it really fast.
And about the response thing, I would like to say that we have a very good communication with the response team. They answer very quickly, and we work together with since a year now. It's everything good. So that's it for us. Thank you, everyone. I hope you enjoyed the talk, and if we have question or everything, don't hesitate to reach us at using the platform or on Twitter or something like that.